Okay, welcome to Zoom Tuesday. I'll go ahead and I will do step 5 in Excel and record this just in case anybody watches it later and wants to see step 5 in Excel. So I'm going to share my screen here. So first of all, I want everybody to know that this is not your data. NYD, not your data. And I'm having a hard time writing that. So I want you to know that because I don't want you to be, I mean, these are not the true numbers that you can use. First of all, I think you have like 200 data points, and you can see here, I think we have about, I don't know, 85 or so subjects. There are 2 hypothesis tests that we want to do. One test is a test on independent means, and the other is a test on independent proportions. So you started looking at this the other day on your step 4. So sorry about that. You started looking at this the other day on step 4, and basically you're going to break the data up into 2 groups and look at the difference in means, and then same idea for a test on independent proportions, except you're going to break it up into 2 groups, and you're going to do a difference in proportions. Okay, so 2 groups that I could look at. Let's see how I could break it up. I could break it up by gender. Okay, so gender would be my independent variable, and then I could see if IQ is different. So I'm going to look at the mean IQ, and that's our dependent variable. Now, even though actually some of you guys had this as a test, I would not do this as a test. In other words, if you're doing gender and IQ as your hypothesis test, then you're going to be writing about that in your introduction, and nobody wrote about that in your introduction. You are probably going to be looking at maybe, oh, I don't know, you could be looking at gender and ADD scores, or you could be looking at, high versus low IQ and ADD scores, or perhaps the English level and ADD scores. However you want to break these people up into 2 groups and and calculate 2 means to see if they're different. So I'm going to go ahead, I'm going to stick with gender and IQ because first of all, I recommend you don't do it, and second of all, that way you won't actually, this will be slightly different. Okay, so gender, I believe 0 is male and that 1 is female. But I'm going to go ahead and I'm going to take all of my data. I'm going to sort my data. Sorry, I just want to sort these ones. Okay, sort by column A. So now it's sorted, and by the way, I had to do this is one person, they're female, let's see, they have, they not repeat, they have a certain level 2, English level 2, they have the English grade, etc. This all is one person, so I need to keep those rows together. So I've sorted all of the, so I selected everything and I sorted males and females. Now, I want to know IQ. So let's see. I'm going to go ahead and take gender and IQ. And I at least copy and paste, and I'm going to paste it over here just so I can see them separately over here. Now, I'm going to take my IQ. I'm going to do IQ for males, and I'm going to do IQ for females. All right, so these are all the IQs for males. As long as gender says 0, whoops, those are all the IQ for males. I'm going to cut that and paste it right here. Now I'm going to go down to where it had the 1s, and I'm going to copy and paste the IQ for females. Okay, so you can actually do the hypothesis test in Excel, or you could copy and paste this into Staccato if you're using Staccato. And if you're using Excel, you'll need to do this first. So you'll need to go to File, Options, add-ins, and you're going to add in the analysis tool pack. All right, so now when I go to data, I can see data analysis. So by the way, if you have a Mac, it's a different, there's a different way of getting that data analysis tool pack. You're just going to have to Google that add-ins on Excel, and you should be able to do it. I can't remember how you do it on a Mac, but it's not too bad if you Google it. Okay, so now I want to know if there is a difference in mean IQ between the males and females that I have here. So I'm going to go to data analysis. And I'm going to do a t-test to sample assuming unequal variances. My variable 1 range are the males. My variable 2 range are the female IQs of the females. All right, I assume that there's no mean difference. I'll use a 0.05 significance level. And let's see what we got. It'll open it up in a new sheet. It'll say that these were the means, this was the mean IQ for males, this was the mean IQ for females. And here's the variance, here's the number of observed, there are 43 males, 42 females. The hypothesized mean difference was 0. We have a test statistic of negative 2.40375 and a p-value. Let's see, we want a 2-tail p-value because this was a not equal to. We're saying were they different. And our p-value is 0.018455. In other words, 0.018 is our p-value, and that is less than alpha. Remember, our p-value is less than 0.05 in this case, and so we would say reject the null. Okay, but I have not actually written this in APA format, so let me go ahead and do that. Okay, so I would say something like an independent, this is my first draft, so bear with me. An independent t-test was performed to determine if there was a significant difference between mean IQs of males and females. Okay, and in fact what we found is that, let's see, the mean IQ for males, and then I'm going to write M, which that's usually X bar, but that's the mean in APA format. It's 96.3, so M equals 96.3. And then the standard deviation is the square root of the variance. Whoops, sorry. Let's try that again. Equals the square root of the variance. This is the SD for males and females. So that's 14.4. Was significantly different from that of females. I'm going to again write the females. So that was, let's see, the females was 103.6. And the standard deviation was square root of 190, which is 13.8. All right, the mean IQ for males, mean and standard deviation, was significantly different from that of females. And then we'll write our t-value. Our t-value was equal to our test statistic, negative 2.40. We'll leave it at negative 2.40. Negative 2.40, and you could have done more decimal if you need to. Sometimes they put degrees of freedom in here. Degrees of freedom, they're saying, are 83. And then we have the p-value, p equal to 0.018. There. And that's it. I'm done with my, that's half of step 5. The other half was the test of proportions. So all you have to turn in for step 5 are 2 paragraphs. So the next one will be an independent test on proportions was performed to determine if, okay, so let's see. Let's go back to our data, and we have to actually figure that part out. So we have, oopsies. I'll go ahead and I will take these people into 2 groups, and I'm going to do high IQ and I'm going to do low IQ, and that is my independent variable. And the high IQ will be greater than or equal to 100, and the low IQ will be less than 100. And then I will do social problems. How about? And so this will just be the percent of people with social problems that have high and low IQs. Okay, so again, I'm going to take all this data and I'm going to sort it by IQ, by my independent variable. Let's see, actually I just want the numbers. I'm going to take these and I want to sort it by H, column H. Okay, so all of these people here are considered the low IQ. All of these people here are considered the high IQ. That's above 100. So I'm just going to take, let's see, I wanted a SocProb and IQ. Okay, so I basically want to take these people into 2 groups, and these are SocProbs, and this is high IQ. See how many the percent of people with social problems with the high IQ. This is the social problems, and this is the low IQ. All right, so here are social problems, and these are the low IQ, and I'm going to go up to 99. And then I'm going to go down, and these are the 100 or above, or the high IQs, and those are the people with, that's the social problem. All right, so let's see here. Now I want to go to data analysis. Oh, let's see. Uh-oh, I can't do 2 proportions on this. So I'll tell you what I'm going to do. I'm going to just take the percentage here. I know that I have a total of, let's see, 0 people out of, in fact, if I just highlight this, you can see I have 42 and the sum is 0. So my proportion for this one, we'll call it X1 and N1. So my proportion is 0 out of, was it 42? I can't remember. Yes. Now the next one, the low IQ, let's see, I have, highlight that, and down at the bottom it tells me that X2, Y2, let's see, out of 43 there were 9, so 9 out of 43, that's X2 and N2. All right, so in other words, I have the proportion of males with, not males, sorry, the proportion of high IQers with social problems is, I believe that was 0, right? Is 0%. The proportion of the low IQers with social problems is, let's see, 9 out of 43, or 20.9%. All right, and again, this is 0 out of 42, and this is 9 out of 43. So I used Excel to go ahead and count these. Now I can do a test on proportions with the 0 and the 9, 0 out of 42 and 9 out of 43. So if I do that in Staccato, and by the way, you can do this on your calculator as well. But if I do that in Staccato, here we go, sorry, couldn't find Staccato there. Then I'm going to do statistics, hypothesis tests, to population proportions. I could put my two samples in, but I actually have summarized data, and that was 0 out of 42 and 9 out of 43. I'll keep my significance level 5%. I'll keep it not equal to. I'm not saying that the high IQers would have a lower or higher social problem rate. And then I click OK. It gives me my test statistic and my p-value. Okay, so here is how I would write this. Okay, an independent test on proportions was performed to determine if the proportion of students with high IQs, and that I'm going to write IQ is, let me write it like this, I'll do IQ is greater than or equal to 100. The proportion of students, with social problems is different for those with a high IQ versus low IQ. And then again, I'll put that is IQ is less than 100. Okay, so out of the 42 students in the high IQ group, 0 had social problems, identified social problems, let's say. Whereas 9 out of 43 low IQ students had identified social problems. And then I'm going to write my z-value. My z-value is my test statistic, negative 3.37. I'm going to write my p-value, and that was 0.0007. And I'm going to say there is sufficient evidence to reject the null at the 5% significance level. There you go. Step 5, ready to turn in. Now, obviously, I want you to think about what test you want to do. At least one of the tests should relate to the introduction. All right, good luck.